Good morning, students. Today I am going to continue square and square roots. In that, we were doing properties of perfect square. So we have completed up to fifth property of square numbers. Now, today I am continuing it and starting the sixth property of perfect squares. The sixth property says that a triplet x, y, z of three natural numbers x, y, and z is called a Pythagorean triplet. Pythagorean triplets. If x square plus y square is equals to z square. That is, for example, for example, 6, 8 and 10 is a Pythagorean triplet. Pythagorean triplet. How? Let's see. We'll see that 6 square plus 8 square is equals to 10 square. That is 36 plus 8 is 64 is equals to 100. So both sides we get 100. This implies, hence we can say that 6, 8 and 10 are Pythagorean triplets. So another example we can show for the Pythagorean triplet is that suppose let the number be, example, let the three numbers be 5, 6 and 7. Let it be. So 7 is greater, so we'll do 5 square plus 6 square is equals to 7 square. Sum of the square of the smaller numbers must be equals to square of the greater number to satisfy the Pythagorean triplet. So it is 25 plus 36 is equals to 49. We see that 61 is not equals to 49. Therefore, 5, 6 and 7 is not a Pythagorean triplet. So for any natural number, that is for any natural number n greater than 1, the Pythagorean triplet is given by, so I must write the formula for any natural numbers n greater than 1, the Pythagorean triplet is equals to, or we can say Pythagorean triplet is given by 2n, n square minus 1 and n square plus 1. These are the three Pythagorean triplet numbers according to this property. Next, another example for the Pythagorean triplet is, if you are asked to find the other two Pythagorean triplet, other two members of the Pythagorean triplet. If one member is 8. So we need to find the other two members. In the first member, solution. First member of Pythagorean triplet is 8. So let 2n is equals to 8. So n is equals to 8 by 2 is equals to 4. First member, that is first member of Pythagorean triplet. So the other member are n square minus 1 and n square plus 1. This will be n square minus 1 means n we have got from here 4 square minus 1, that is 60 minus 1, that is 15. And the next one is 4 square minus plus 1 is equals to 60 plus 1 is equals to 70. Hence, the other two members of the Pythagorean triplet is 15 and 17. First member is 8, then the other two member is 15 and 17. This is the example of this question. Now next, the seventh property of Pythagorean triplet. Seventh property of perfect squares. The square of a natural number is natural number, let it be m. Square of a natural number is m is, so what is the next seventh property? Square of a natural number m is equal to the sum of two consecutive positive integers. Two consecutive positive integers. Matlab, the square of, this is the wrong one. I should change this one. Actually, the seventh property there was a difference in that. So the seventh property of perfect square is the square of a natural number m is equal to the sum of the first m odd numbers. Example, we can see here. Example, 1 square is equals to 1. That is equals to sum of first one odd number. Now 2 square is equals to 4. That is equals to 1 plus 3. 2 sum of, that is equals to sum of 2 odd number. Sum of first 2 odd. 3 square equals to 3 3 is 9. Means 1 plus 3 plus 5. That is sum of first 3 odd number. In the same way, 4 square is equals to 16. That is equals to 1 plus 3 plus 5 plus 7. 1 2 3 4. That is sum of first 4 odd numbers, and so on and so on. Next, now let's come to the eighth properties of perfect square. Eighth property is we can express the square of any odd number as the sum of two consecutive positive integers. We can express the square of any odd number as the sum of two consecutive positive integers. That is, example, we can see sum of two consecutive positive integers. Look here. Suppose 5 square can be, 5 square is 25. This can be written as 12 plus 30. This is the sum of two consecutive integers, 12 and 30. In the same way, 12 square or whatever, but we have to see that it should be in odd numbers. It should be odd numbers. We can express the square of any odd numbers. Odd numbers. So 5 square, then come to the 7 square. 49. What we can write? 24 plus 25. This is the two consecutive natural numbers, positive natural numbers. Another odd number, square of the odd number can be 11 square is 121, and that can be 60 plus 61, and so on and so on. So by this we come to know that the square of any odd numbers can be written as the sum of two consecutive positive integers. Note that here one thing should be noted, that the converse of the above statement is not true. That is, we cannot add any two consecutive integers to make a perfect square of odd numbers. Like, suppose 15 plus 60 is a consecutive numbers. It gives you 31. It is not a perfect square. It is not a perfect square. So this is the thing. The converse of the above statement is not true. Now, come to the next property, ninth property of perfect square. For any natural number n greater than 1, any natural number n must be greater than 1. For any natural number n greater than 1, n plus 1 into n minus 1 will be equals to n square minus 1. That is the identity we know this here. The identity we use, a minus b into a plus b equals to a square minus b square. The same thing is being applied here. Using this property, we can find the product of two consecutive even or odd natural numbers. We can find the product of two consecutive even or odd natural number. Easy. Let's see. Suppose, example, 7 into 9, two odd numbers. Product of two odd numbers can be written as, we can see 8 minus 1 into 8 plus 1. A minus b into a plus b. We know that. A square minus b square. This one is 1 square means 1. So it will give you answer. It is 64 minus 1, that is equals to 63. Similarly, some other numbers we can take. Let it be 15 into 17. We see that these two consecutive odd numbers. 15 के बाद दूसरा जो consecutive odd numbers आता है वो 17 होता है. तो हम देखेंगे, we can write 16 minus 1 and this is 16 plus 1 17. 16 minus 1 is 15 and 16 plus 1 is 17. We have changed this one. Now this will give you 16 square minus 1. Okay, now that is 16 square is 256 minus 1 is 255. And this is the now let's see the consecutive even numbers. Two consecutive even numbers. Let the first consecutive even number be 14 and the second will be 16. 14 and 16 is the consecutive even number. 14 is 15 minus 1, 14. So 14 into 16, these are the odd number, even number, consecutive even number, which can be written as 15 minus 1 into 15 plus 1. And we get 15 square minus 1. That is 225 minus 1 is 224. Like this way, we can find easily. So, and so on. And let's see one more consecutive even numbers. Let it be 22 into 24. So 22 can be written as 23 minus 1 and 24 can be written as 23 plus 1. So what we get? 23 square minus 1. And this is the answer we get. Next, 10th property in the next. The 10th property is there are 2n, 2 times of n, non-perfect square number between the square of the two numbers n and n plus 1. Suppose the two numbers, squares of the numbers n and n plus 1, there are two numbers. So the number of non-perfect square number will be 2 into n. Let's see with example. Suppose 1 square is equals to 1 and 2 square is equals to 4. So here we see that n is here and n plus 1 is here. The square of this will be, we say that between 1 square equals to 1 and 2 square equals to 4, there are 2, 3, that is, there are 1 square and 2 square. The numbers are 2, 3. That is, there are 2 into 1, that is 2 non-square numbers. Another example we can write is 2 square equals to 4 and 3 square equals to 9. You see, there are the number are 5, 6, 7 and 8. The number are 5, 6, 7, 8. So which lie between 2 square and 3 square, which lie between the 2 square and 3 square. Therefore, there are 2 into 2, that equals to 4 non-square number. So in this way, another example we can do that. The example is the first example. Third example, let's see one more example. Let's see two numbers. 3 square is equals to 9 and 4 square is equals to 16. Two consecutive numbers. You see, 3 square and 4 square. Between 3 square and 4 square, there are 10, 11, 12, 13, 14 and 15. So this means that is there are how many? 1, 2, 3, 4, 5, 6. There are 2 into 3. 2 into 3 is equals to 6 non-square number. So this is the 10th property. So we will do the exercises after this property.